Hello everyone. Today let's previously we are done with the this one. Basically what we did, um, stack and queue based algorithms, right? So we are done with the very important four algorithms. Basically we started with a monotonic stack, and we did basically we completed monotonic stack, monotonic queue, expression evaluation, this one, and stock span, this one algorithm, right? So today we'll be discussing on the we'll be starting with the basically tree based algorithms, right? So tree traversal or tree based algorithms. First we'll be going with the DFS and BFS tree traversal algorithm. So we'll be discussing the DFS and BFS tree traversal algorithms, right? So let's get into the definition, but let's see what is DFS here. DFS is nothing but the depth first search abbreviation. Basically it explores a tree or the graph by going as deep as possible along one branch before backtracking. Again, so DFS, also known as depth first search, explores a tree or a graph by going as deep as possible, right? So this is depth first search, right, along one branch before backtracking. So this is fine. Next, let's move on with the BFS, basically breadth first search, right? So this explores a tree or a graph level by level, visiting all the nodes at the current depth before moving deeper. So this is fine. So let's move on with the explanation here. So DFS can be implemented recursively. Again, DFS can be implemented recursively, stack via function calls, or iteratively using an explicit stack, right? So let's see that when we implement in the form of this one algorithm or the code using the Python programming language, right? So this is fine. Now let's move on with the BFS. BFS is basically implemented using a queue, basically, right? So this is FIFO order. FIFO order in the sense first in first out, right? So to explore the nodes level by level, right? So each level, right? So this is fine. So both drivers are fundamental for understanding tree or graph algorithms, such as shortest paths, connected components, and the cycle detection. So this one we have to keep in mind, right? So now let's start writing the algorithm so that we'll get to know this one correctly. All go correctly, right? So first let's go with this one, what we call DFS. So we'll be going with a recursive DFS, right? So I just insist you to try out iteratively as well using the explicit stack. So for this particular example, I'll just be going with a recursive DFS, right? So first let's do one thing. Let's define a node structure for our tree first. So sorry, where am I writing, man? So here, so this one will be class node. So this is fine. First it will be init. So this one will be self, comma, value. So this is fine, man. Next let's do one thing. Let's store the nodes value. So I'll just go with the value equals value. Next is left. So just go with the self dot left equals none. This one none. Also next one is self dot right equals, so this one will be none as well, right? So this is fine. So the next step would be, so here let's implement the DFS, nothing but a recursive. We are going with a recursive DFS, right? So I'll just go with a def. So let me name this one DFS itself, as we are going with the recursive DFS. So we need the root as parameter, right? So first let's go with the base case. If node is none, if we don't have any node, then we have to exit, right? So then I'll just give the return here. So if not root, then let me give here a return, right? So just for the sake of exiting. So here in this case we have to visit the current node. So let me give something within the print for interactive purpose. So this one will be root dot value. So this is fine. End equals, so this is also fine. The next step would be, we have went with the print. This is fine. So as I've said, we'll be going with a recursive DFS, right? So let's recur the left subtree, meaning, so let me make use of function name here, and we are recurring the left subtree, right? We are recurring for the left subtree, sorry. So this one will be root dot left. If I give left, this is fine, right? Same, let me copy the same thing here and instead of left, let me change this one to right. We are just recurring for the left and right subtrees. So this is fine. This is it for the DFS. Very simple. Now let's implement the BFS as well. BFS, for the BFS, always remember one thing: for the DFS we make use of the stack, for the BFS we'll be making use of the queue, right? So this is basics and we have to know this at any cost. This is fine. Always remember one thing: for implementing the DFS we can either implement that one recursively, as I've said. So I during the explanation I said that so DFS can be implemented recursively, that is by making use of the stack via function calls, or we can implement the DFS iteratively as well using the explicit stack, right? So always remember one thing: DFS can be implemented recursively or iteratively. Mostly we'll be going with a recursive DFS. We'll be making use of the recursive DFS when we are solving the problems, tree based problems. But we will be making use of using this one, what do we call, iterative DFS, when for the extreme optimization. For the extreme optimization, in my case I have made use of the iterative DFS for the extreme optimization, to avoid the MLE when the constraints are very tight. We need extreme optimization. In that case it's usually this one, what do we call, it's better to go with the iterative DFS rather than the this one recursive DFS, because iterative recursive stack will can take up to big often, most probably most of the times, right? So iterative this thing, it avoids the overhead basically, right? So that is the reason it's better to go with the iterative DFS for the extreme optimization, and this one, what do we call, to avoid the MLE basically, usually, right? So this is one of the reasons we make use of iterative DFS, and usually for solving the problems, most of the problems will be going with the recursive DFS itself. So it's simple, it's easier, that is the reason we go with the recursive DFS. Now, and one more thing I want to say here: BFS is breadth first search, right? So BFS is implemented using a queue, right? FIFO order, nothing but first in first out order, just to explore the nodes level by level, right? So this is nothing but BFS. So let's implement the BFS using queue. It is always implemented using the queue, right? So BFS is not implemented using the stacks. BFS are implemented using the queue, right? So as it is implemented by the queue, so I'll just give here from collections. So let me make use of the DQ here. Let me import DQ basically, right? So DQ, this is fine. Yep. Now let's do one thing. Let me go with the function name BFS here, and again we need root for this one as well. We have to start with the root itself, right? So this is fine. First let's initialize the queue. Queue equals so let me call the DQ here. This is fine. Next step would be we have to start with the root node, as I've said, whether it may be BFS or the DFS, right? So this one we let me append this one root to the queue initially, right? So this is fine, man. Let's go with the while loop. So while of queue, this is fine. We have to pop from the front of the queue, meaning so node equals queue dot, so this one will be pop left, right? So this is fine, pop left. Next thing would be, let's go with a print. So this one will be node dot value, this is fine, node dot value, end equals, yep, this is fine. So we are popping from the front of the queue. First what we have done, we are visiting the current node, right? So we are visiting the current node. So just for the sake of interactiveness, I have made use of the print statement. Here we are visiting the current node, this is fine. Let's write the simple if condition here, because if the child if the left child exists, then we have to push that one to the queue, and also if the right child exists, then we have to push that one to the queue. In simple terms, if the left and right child exists, then we have to push them to the queue, right? So let's write the simple if conditions, basically two if conditions. This one will be node dot left, so this is fine. The next step will be q dot append, so this is fine, q dot append node dot left. Yep. Now if node right, this is fine. This one will be q dot append, So this one will be node dot right. So this is also fine, I believe. Right, so we are done with this part. We are done with the this one DFS and the BFS. This is it for the algorithm, basically simple, right? So as we are making use of the Python, it makes the code even simpler, simpler to the core actually, right? So this is fine, right? So this is it for the BFS basically, right? Now let's go with the example usage. So let's consider, let's build a sample tree. So let me show this one in the terms of diagram. So I'll just give me a second here. So let's consider this one, man. Let's build a sample tree. Let's go with the root 1 here, this one, and let me go with 2 here, left child, and this one 3 for the right child, right? So also for the subchildren, let's for the 2, let's go with the 4 and 5 here. So this one 4 and this one 5. This is fine, and this one we just have 6 here. Let me give 6 only the right this one subset, right, for the 3 basically. So this is the example that we'll be going with. Just remember this one, right? So this is the example that we'll be going with, right? So just try to visualize this one. So let me give here root equals node of 1, right? Again root dot left here, this is equal to node dot node of 2 basically, and root dot right here, so this one equals node of this one 3. This is fine. Next let's go with a root dot left, so this is equals node of 4. This is fine. Next let's go with a root dot left dot right, so this is equals node of 5. So this one will be root dot right dot right. This is equals node of 6 month. Yep, 1 2 3 4 5 6, right? So I showed you the diagram already. So this is nothing but we have, I showed you the build, right? So again let me show this one. We have considered this one. 2 left, root dot left we considered, this one has to be 2, and root dot right we have considered 3. This one has to be 3, and root dot left, so this one basically the this one, what do we call, subchild, right? So this is the this one, what do we call, left subchild for the left child for the 2 basically. So this one will be 4, and root dot left dot right, so this one right child for the 2, so this will be 5, and finally we have only right child for the this one, what do we call, see here, root dot right, so this one node 6 basically, right? So this is the build, right? So I have shown you the build. So this is what we have considered here as well, right, for the example usage basically, right? So now what we need to do, we have to run the traversals basically, DFS and the BFS. DFS meaning, so it will go at depth, either it will go this side first and this side like this. So BFS is nothing but it will go level by level. First level is this one, basically indexing starts from 0, so here, and the second level is this one, we have both the subtrees, so this one will be we have to consider this one as 0th level, first level, and the second level, because indexing starts from 0 basically, right, for the trees. So this one is 4 5 6, this is the second level, 0th level, first level, second level. If indexing we consider from 1, it will be 1 2 3 3 levels, right? So this is fine, man. I hope this part is clear. Let me remove this one. Now let's run the traversals, right? So depth and breadth, so basically this one terms itself say the meaning, right? So let's run the traversals. So I'll just go with the print. So this one will be DFS traversal. This is fine. Now let me do one thing. So this one will be DFS of, so this one will be print this one will be slash n. This is fine. BFS traversal. So this is also fine, just for the interactive purpose, right? So let me call BFS here, function BFS of we have to start from the root, so I'll just pass the root here. Same goes with the similar to the DFS function we have called, and along with the we have to start with the root. Same for the BFS as well, right? So now if I run the code, output that I need to get here is for both. For this one it has 1 2 3 4 5 1 2 4 5 3 6. So as we are performing the DFSC, this one has to be 1 second, 1 2 3. So instead I would have written this one in the notepad, man. So this is fine, extra work here. This is fine. For the DFS, first what we will do, it will go depth, right? So this one we are searching based on the depth, basically 1 2 4, right? Then comes the 5, basically. Then comes this side 1 2, this one 1 2 we have already done, we have marked this one 1 2 4, then we are left with 5. This depth is done. Then we will go for this one is already marked, so 5 is already marked. Then we will go with the 3 and then 6. So this one will be 1 2 4 5, this one 3 6. So this is for the DFS, basically, right? So this is for the DFS. For the BFS, so we have to go level by level, right? So we have to go level by level. For first it will be 1, so 0th level it will be 1, basically. So I'll just write it over here, 1, followed by the next level. Here we have left and the right children, so first it will be left, then it will be right, it will be 2 3, right? It will be 2 3. Next we are done with the first level. So now let's move on with the second level. The first one here would be 4, followed by 5, followed by 6, right? So it would be 4, then it would be 5, then it would be 6, basically, right? So this is fine, I believe. 1 2 3 4 5 6, right? 1 2 3 4 5 6. So this is for the BFS, right? Level by level. So this is based on completely depth, basically, and this is based on completely breadth. This is based on the depth. So we go depth, right? And this is based on the breadth, so we go level by level, right? So this is fine. So this is it for the BFS and DFS part. So let's run the code, whatever we have written. So output, we know what we need to get. So let me just give me a second here. Let me give Control J here. Yep. So let me copy this one. Just give me a second here. Yeah. So I'll just type Python followed by file name. So yeah, see here, the DFS traversal we have got 1 2 4 5 3 6, and BFS traversal level by level 1 2 3 4 5 6. We have got the absolute desired output, meaning we have got the correct output as well, right? So I have showed you the same thing here. I had showed you same thing. Why DFS traversal, this one goes with 1 2 4 5 3 6, because it is based on the depth, and BFS traversal, why it is 1 2 3 4 5 6 instead of 4 5 3 6, right? So because this goes level by level, right? This is fine. Right, now we are done with the DFS and BFS tree traversal algorithms, right? So this is basically combination of two different algorithms, DFS and BFS. So I have considered this one because we have many algorithms in this one, man. Trees almost we have 14 algorithms, I believe. Every algorithm is important, basically. That is the reason I have considered this one. I have merged this one both, basically. So next we'll be going with a Morris traversal algorithm, right? So this is also one of the very important tree based algorithm, Morris traversal, basically, right? So now we are done with the DFS and BFS tree traversal algorithm. Let me do one thing. Let me summarize whatever we have learned so far, right? So DFS, what it does, it explores a tree deeply first before backtracking. What it does, DFS explores a tree deeply first before backtracking, and BFS explores a tree level by level using the queue, right? So DFS is useful for pathfinding recursion based problems, while BFS is powerful for the shortest paths in the unweighted graphs and level order traversals, right? So this is it for the BFS and the DFS. I hope this part is completely clear, man. I hope this part is completely clear. Again, DFS explores a tree deeply first before backtracking. Again, this is one of the important points. And BFS explores the tree level by level using the queue. We know this. And just keep this in mind, DFS can be solved by this one, recursively and iteratively as well, right? So and one more thing, it is solved using the stacks itself, and BFS will be implemented via queue. Always remember this, right? So this is basics, but you have to know this at any cost. So for the BFS DFS, we will be going with the stacks, and it can be solved using it can be solved recursively and iteratively. For the BFS, we'll be implementing that one via queue, breadth first search, right? So this is fine, I believe. Finally, the last point here would be DFS is useful for, basically it is useful for the pathfinding as we go depth, right? So DFS is useful for the this one pathfinding recursion based problems, as well as we can go with a we usually go with a recursive DFS. Most probably most of the tree problems we solve using the recursion itself, because it's easy, the code is simpler. Usually we opt to go with the this one, what do we call, recursion, or the recursively we try to solve the problem. Most of the tree problems, as I've seen, mostly we will be going with a recursive DFS, right? So usually it's very rare that we go with the this one, what iterative DFS, but we go with the iterative DFS when it is needed, when to avoid the MLE, right? Or to avoid the extreme this one, what do we call, optimization. Usually we'll go with the this one, BFS, right? Also known as breadth first search, right? This one, sorry, iterative DFS, sorry, iterative DFS, right? So this is fine. So it is useful for the pathfinding recursion based problems usually, right? So while BFS is powerful for the shortest paths and unweighted graphs and level order traversals, right? Usually you would have heard of this one, in order traversal, pre and post. So this one we have solved n number of problems in the LeetCode. We have solved many problems in the this one Codeforces as well, using the Node.js, using the this one Java. So also I have started to this one code in the Python as well. So we have solved n number of problems using these this thing, programming languages, these three programming languages basically. Started with the JavaScript or the Node, so we went completely in depth with the this one Java as well, and a bit on Python as well, right? So I believe so we are done with this one. I believe we know this one correctly now, right? So now we are done with the DFS and BFS tree traversal algorithm, right? So next, as I have said, we'll be discussing on the Morris traversal algorithm. For now, this is it. Thanks for watching, guys.